Mathematicians, let's talk about reflections. No, I don't mean reflections like looking in the mirror. In real life, that's what we think of probably when we hear the word reflection. You look in the mirror and you see yourself exactly as you are, just on the other side. If I'm really close to the mirror, my reflection is going to look really big and like it's really close on the other side. If I'm really far from the mirror, my reflection looks like I'm really far away. But notice that if I'm right here in the middle of my little screen at the bottom, then my reflection, which is the actual video that you see, is in the same spot I am. I'm not looking diagonal and seeing my reflection. It's right across from you. And that is actually how reflections work in math. So when we're talking about math, a reflection means you've got this point and it's going to show up on the other side of a line that you define. In 6th grade, it's mostly going to be an axis, the x-axis or the y-axis. Now, some things are going to change, some things are going to stay the same. But when we reflect a point, only one of the coordinates is going to change. Not both of them. You're not moving to somewhere totally different. There is something similar about you and your reflection, and that's the one point that stays the same. There is something a little different about you and your reflection, and that's going to be the coordinate that changes. So if we are reflecting over the x-axis, remember x goes side to side, then the y-coordinate is actually what's going to change, and it's going to change to the opposite sign. When we reflect over the x-axis, the x-coordinate is going to stay exactly the same. Let's look at the example in our notes right here. This is my x-axis, x reflection. I find it's really helpful for me if they say reflect over the x-axis, then I just like highlight or draw an extra line across my x-axis just so that I'm not accidentally reflecting it over the wrong axis. I like to really see it. Now you can see there are 2 points here. I know that the original point is the letter P because when we reflect a point, it looks the same, just a little bit different. You can see that little line next to it, kind of like an exponent or like a single quotation line. That's called P prime, and that's the reflection. So we're starting at point P. It looks like it's at 5, 7. We are going to reflect it like it's looking in the mirror of the x-axis, and its reflection is exactly on the other side of the mirror right there. We reflect it across. So if my reflection is 7 spaces from the mirror, then, or if I'm standing 7 spaces from the mirror, my reflection is also going to be 7 spaces to the mirror, just on the opposite side. So watch how the x-axis, the x-coordinate stays the same, but the y-coordinate shifts to the opposite of positive 7, negative 7. If we reflect over the y-axis, it's actually the x-coordinate that's changing to the opposite sign, and the y-coordinate is staying the same. Here's my y-axis. Here's my original point P. It's at 2, 3. Notice how if we're reflecting across the y-axis, the y-coordinates stay the same, and the x-coordinates change to the opposite sign. P prime is the opposite of positive 2. It's now negative 2. Okay, let's do an example that wasn't already done out for us. You're going to see a lot like this today. Reflect over the x-axis. And then it might give you a picture, or later I might even just give you the words and you have to tell me the new ordered pair. But we'll start with pictures. Here is point 2, down in the 3rd quadrant. I'm always going to start by writing my ordered pair. Sometimes you have to find it, sometimes it's up in the directions, -5 and -8. And I'm going to reflect it over the x-axis. Like I said earlier, I'm just going to draw a line just to remind myself this is my mirror that I'm reflecting it over, not the y-axis. Because if it's multiple choice, there's probably going to be a reflection over the y-axis as like the fake wrong answer. Okay, so x-axis means that my y-coordinate is changing. Another way to think about it is reflecting over the x, x stays the same. Reflecting over the y, y stays the same. So x is going to be the same negative 5. That's because it's going to have to appear somewhere on this line that I'm not very good at drawing very straight. But somewhere on this line is like when you stare into the mirror and your reflection is staring right back at you. It's not to the side, it's not to the other side, right down that line. This was 8 spaces from 0 on the negative side, so my new point is going to be 8 spaces on the positive side. Oops, I drew the ordered pair kind of low, but this is the point, Q prime, and that's the ordered pair. Reflecting over the y-axis goes up and down. Y is going to stay the same. I'm starting at negative 5, positive 4. Y is going to stay the same because I'm not moving off of this positive 4 line. But now it's going to be in quadrant 1, this G prime, and that will be positive 5, positive 4. Another way to think about this, so you're not stressing about like which one changes, is you can take G, reflect it over, and think, oh, I know that quadrant 1 has all positive values. I know that quadrant 2 has negative x's, positive y's. So that's a good way to like double check your answer. And those are reflections over different axes.